Okay, the QuickSort explained in plain English. QuickSort explained in plain English. Why do I feel the need to make this video? Oops. I made this video because I actually had kind of a bit of a hard time picking up on this one. But if you stick with me, watch the video the whole way through, maybe even subscribe and give it a thumbs up. Or depending on where you're watching this, comment, like, subscribe, all that kind of stuff. I'll explain to you how QuickSort works and how you can actually move this to code. So the concept behind QuickSort is you have a point, a value in your data set that you're going to compare everything else to. If the value that you're comparing let's call that the pivot. If the value that you compare to that pivot is less than it, it's on the left. If it's not less than it, it's on the right. If it's equal to it, it's also on the left. But what's a conceptual way of doing that in a way that is very code translatable? I want to show you that method. Okay, 3, 7, 8, 4, 1, 2, 5. I've color coded some things here. The red is my pivot. The pivot is the thing I'm going to be comparing to all the time, and then changing as we do iterations. Blue is the value being compared to the pivot. The green is a swap to index. If I find something less than the pivot, I know where that number that's less than the pivot should actually wind up going. That's what that swap's going to tell me. And I'll do a little more talking about that too, and it will all make sense. Okay, so right now, the value being compared to the pivot is 3. The swap to index starts also at the far left as well. And my pivot, the pivot is randomly selected. Since it's randomly selected, I can put it anywhere I want. I'm putting it at the end. Okay, the question that you're always asking in this is, so you have like one pivot point, but what's the next pivot point? So I'm going to compare everything to 5, but then after that, what am I going to be comparing values to, and then how am I going to split up the array going forward? Because this is a divide and conquer style of algorithm. Where do I divide? What's my new pivot? That's what you have to answer. Okay, so I compare 3 and 5. 3 is less than 5. So what happens when it's less? We would swap the value being compared to the pivot is less than the pivot. We swap the values sitting at the indices of the value being compared to the pivot here, and the swap to index also here. If you had a swap function, you can check to see if those indices are the same. If they're the same, don't do any work. You could swap them, but it's extra work that's not necessary. So they're equal, don't do any work. Okay. The next thing to remember, if it was less than, you want to keep those numbers that are less than the pivot on the left-hand side. How do we do that? Well, we take this swap to index and we move it over to the right. That way I'm not going to swap any values to the left. Any values that have already been swapped to the left are not going to be overwritten. So I keep saying, okay, where am I going to move something to? I'm going to move it to wherever the swap to index is. In other videos, it's also called a partition index. All right, so my value to compare to and my swap to index have both been incremented. I'm still comparing to 5. Is 7 less than 5? It is not. Have I swapped anything? No. So don't move the swap to index. Don't move it. But I do need to move the index of the value that's being compared to the pivot. Is 8, sorry, it's pointing at 8. Is 8 less than 5? It is not. Swap to stays the same. Okay. Value to compare to, different. Is 4 less than 5? Yes, it is. Okay. We have our first major swap. So my swap to index is at 7, or at position 1. My value being compared to the pivot is at position 3. Swap 1 and 3. So 4 goes over here, 7 is over here. Good thing to move that partition index, or else it would have overridden the 3. That would not have been good. Okay, I'm going to pick up the pace a little bit now. So we swap 4 and 7. Now we compare 1 to 5. When I was less than 5, my swap is back here. I swap 1 and 8. 1 8 have been swapped. Now 3 4 1 7 8 2 5. 2 rows less than 5. My swap to index is now sitting at 7. I swap where 2 is and where 7 is. I swap those two. And now the interesting thing is that now my swap to index and my not my swap to index, my pivot index and my value being compared to the pivot index are the same. Okay, that means stop, don't loop anymore. It means everything, there's a point where everything is less than 5 and everything is greater than 5. That point happens to be at the swap to index. So 3, 4, 1, 2 are all less than 5, 8 and 7 are greater than 5. It just makes sense because I'm at the end and the last numbers that haven't been swapped are still sitting here at the swap to index. So 8 and 7. How do I make it so that everything greater than 5 is to the left of it? Swap your excuse me, swap your pivot or the value being compared to the pivot because it's at the same point with the swap to index. So now 5 is here, 8 is here. Look at that, 3, 4, 1, 2, less than, 7 and 8 greater than. All right, I got about 2 minutes left before I lose everyone's attention. Okay, so now recursively we would have 3, 4, 1, 2 is now a new array, and 7 and 8 is now a new array. The pivot index you leave alone. We don't want to compare anything to that anymore because it's already done. Everything to the left of it is less, everything to the greater than is right. So we started the 0 index up to 3, so 3, 4, 1, and 2, and then the 5th and the 6th index as a different array. So we run the same process, 3, 4, 1, 2, right? So this is our pivot, this is our value being compared to, this is a swap to index, works the same way. 3 is not less than 2, don't do anything with it, move the compared to over. 4 is not less than 2, don't do anything with it. 1 is less than 2, swap that with the swap to index. Goes here, goes here. I have 1, 4, 3, 2, we're in this situation again. So I have 1, 4, 3, 2. Yeah. So again, we want that pivot to be in the right place for the next time we come around. So same thing we did before. Swap the value at the swap to index and the value at the pivot index. So now you have, look, 1, 2, 3, 4. Isn't that something? All right, I got about another minute here. So now when this goes back through your recursive call, this here, right, 2 becomes the pivot. So I have an array of 1, and it's a length of 0. Or I should say, the left and the right index are the same. I have 3 and 4. I have to deal with that. So that goes back through the recursion. Compare 3 with itself. Well, or compare 3 and 4, yes, 3 is less. We got about 30 seconds. I can swap it if I want, but I don't need to because I've been swapping it with itself. And 4, and so right, this we wind up over here. And now the time that this comes back through, right? And only this was now my pivot, so that doesn't go anywhere. The 3 goes back through the recursive call. It's length 0. And now what's happened is, since if you declare, you can return the array. You can return the array every time. But if that array is essentially visible to all those different function calls, you don't need to pass it around necessarily. Your array is now ordered, because look what happened here. You ordered this side to be 1, 2, 3, 4. The 5 was a pivot. The 5 comes back. The 5 is there. 7, 8, we didn't go through that whole thing on 7, 8, but the 7, 8 works the same as the 3 and 4 did. So 1, 2, 3, 4, 5, 7, 8. You're done. So I'm going to make another video showing my code. I will attach my GitHub and everything to this video, but I'm going to make another video explaining how I translate this in the code. Thanks a lot. Have a great day. I'll see you guys soon. Get my little mouse here. And adios.